This short video presentation will discuss and show how land and sea breezes form. First, let's begin by discussing what we already know about winds and how they form. We've learned that winds are created by unequal heating of the earth, which results in different air pressures around the earth. So, for example, we know that at the polar regions, air tends to be cooler. And we know that cooler air has relatively high pressure. We also know that near the equator, the air tends to be warmer. It gets more direct sunlight from the sun. So warmer air tends to have lower pressure. These differences in air pressure cause the air to move from areas of high pressure to areas of low pressure, creating winds. So why do different temperatures of air have different pressures? Remember that, for example, in cold air, the molecules move a little less rapidly, so they get a little closer together, making the density greater. In other words, in the same amount of air, there would be literally more molecules in cold air, as opposed to warm air, where the molecules move a little faster. As a result of that speed, they move farther apart, and then that air then has fewer molecules in the same amount of space. Therefore, it exerts less pressure. So, with colder air, you tend to have higher pressures. With warmer air, you tend to have lower pressures. So how does all of this relate to land and sea breezes? Well, maybe you've spent some time in Florida on the beach on spring break, and you notice during the day that, sometime after noon, it starts to get windy with that wind blowing off the ocean. And sometimes you might even have afternoon thunderstorms. Now, you don't have to go all the way to Florida to feel this. Maybe you spent time on a beach on Lake Michigan or Lake Huron, and you've noticed the same thing. Sometime in the afternoon it gets windier, then it gets cloudier, and maybe you get a little afternoon shower. So why does this happen? During the day, along a beach where the water is close by, what happens during the day is because land heats up faster than water does, the land doesn't circulate like the water does, so it's much easier for the sun to heat up the land. The air near the land gets warmer than the air around it, and it begins to rise. This rising air produces an area of low pressure. Now, as that air rises, it starts to cool, so its pressure goes up a little bit, creating a little bit higher pressure up above. Anytime you have rising air, especially if it's humid air, you have the possibility of cloud formation. So that's why in this situation, sometimes you have those afternoon thunderstorms or rain along the beach. Now, this still doesn't explain why we have something that results called the sea breeze. Well, we have our lower pressure air above the land rising. Air from somewhere needs to move in to take its place. And that air is from the cooler air that's above the water. That air has higher pressure, so that air moves in off the water, and we call it a sea breeze, or along the Great Lakes you might call it a lake breeze. But in science we tend to refer them as sea breezes. So we have this circulation where warm air is rising off the land, and we have the cool air moving in off the water to take its place. Now, there's also things going on above the land too. That air near the water has relatively high pressure, but the air above it has relatively low pressure. And then this air starts to move down to replace it, and it starts to cool when it gets close to the water. And then that air that got a little bit higher pressure above the land circulates across to fill that space. And it'll carry the clouds sometimes with it as well. And that's how a sea breeze forms. At night, an opposite situation sometimes sets up and creates what we call a land breeze. Now, if you spend time along a lake or an ocean, you may have been less likely to notice this because in the middle of the night you're sleeping. But sometimes you might wake up to maybe a late night thunderstorm or rain, or maybe you'll just wake up and you'll hear the breeze. And what you're hearing or seeing is what we call land breeze. Now, how this works is at night, the land cools more quickly than the water does for the same reason why it heats up faster, because it's not circulating. So we have a situation where the land ends up getting cooler than the water does. And the water retains its heat much better since it circulates, so it often is warmer. And if you've ever done late night swimming, you know it's actually quite comfortable because the water tends to be a little warmer than the air does. So again, wherever we have warmer air, it begins to rise, creating an area of lower pressure. And as it gets higher up, it starts to cool again and creates an area of higher pressure. Well, we have this air rising. Some air needs to move in to replace it, and that comes off the land. The air above the land, again, is cooler because the land cooled faster, so that has relatively high pressure. So air moves from high to low, and this creates what we call a land breeze. Now, just like with the sea breeze, there's some things happening above as well. Above the land that's been cooling, the air has relatively lower pressure, less dense air above the ground, and that starts to sink to move in to replace the air that moved off the land. And above, we have the air moving from the higher pressure over to the lower pressure, creating this circulation. And again, anytime you have rising air, if it's humid enough, especially since it's coming off the water, you can get some cloud formation. And again, you can get some rain as a result of that. And those clouds might move right over to the land since there's that circulation above the ground. But again, in summary, a land breeze is created in the middle of the night when the water is warmer than the land is, so the air rises off the warm water and the air moves in off the cool land to replace it. And again, we call that a land breeze. Land and sea breezes can also set up over much wider land areas than just, let's say, along the coast of Florida or along the shore of Lake Michigan. They can also cover large areas of continents and last and set up for months at a time. And we call those monsoons. And you may have heard about those in your social studies classes. So, for example, in a landmass that's as big as Asia, in the summertime, the water or the land heats up very, very quickly. So it'll tend to be warmer than what the ocean is, which will tend to be cooler. So you get higher pressure over the ocean, and you get lower pressure over the land. And since air moves from high to low, you get these winds that blow in off the ocean, and we call those monsoons in Asia and into India. And in that time of year, that would be considered the wet season or the rainy season. During the winter months, the opposite situation will set up where the sun is heating the land less directly. So the land tends to be cooler and have the higher pressure air, while the water tends to be warmer with the lower pressure air. And since air moves from high to low pressure, you have a giant land breeze that sets up. And we tend to call that, for these areas of Asia here, the dry season, where there's a lot less moisture. And again, problems can happen when these land and sea breezes don't set up properly for several months of the year, and you can get areas of drought, or you can get way too much rain in areas of flooding. And monsoons will set up in various places around the world. For example, South America might get them. Southern California, you might get some monsoonal land and sea breezes that set up for long periods of time. But the science behind it is the same. It's all about where there's cooler areas and where there's where there's warmer, low pressure areas. So let's review what we've learned in this presentation. For sea breeze formation or lake breeze, if you're along a lake, step one is you have warmer air over the land since the land heated up faster and that air is rising. That creates a low pressure area over the land. As it rises and cools, it forms a higher pressure area above the ground because it's cooling. Above the water, it's a little lower pressure since the air is less dense above the ground or above the water. But above the water, because it's cooler, it has relatively high pressure. And this causes a breeze to blow in off the water to replace the air that's rising over the land. And we call that, again, a sea breeze. Now above the ground, you have to complete the circulation. So air from this relatively high pressure is moving back across to the area of relatively low pressure. And you have this circulation that results in a sea breeze. At night, everything tends to reverse. You have areas of rising air above the warmer water, since the water cools more slowly than the land does at night. And then that creates an area of lower pressure above the water. And above, when that air starts to cool again, you get an area of higher pressure. Above the land, you have an area of relatively low pressure, since the air is less dense above the ground, and an area of higher pressure because the ground is now cooler than the water is. The land is cooler than the water. And this causes, again, the air to move off the land back over to the sea or to the water. And we call that a land breeze, since that's the direction that the air is coming from. And again, above the ground, we also have the rest of the circulation, where the air is moving from the high over to the low. And again, this circulation sets up, which we call a land breeze. Land and sea breezes don't happen every single day of the year. So what can stop a land or sea breeze from setting up? One thing that can stop a land or sea breeze from setting up is it could just be a cloudy day. If there's not enough sunshine getting through, then you don't have the land heating faster than the water or anything like that setting up, so you don't get a land or a sea breeze forming. You could also have a weather system moving through. In other words, you could have a couple of different types of fronts that are approaching, or even a low pressure system that's moving through the area, and that type of weather takes over instead of allowing a land or a sea breeze to set up. You could also have a storm that rolls through, for example, a hurricane as an extreme example. But if a storm moves through, then of course those weather conditions are going to take over, and you're not going to have a land or a sea breeze that sets up. Thank you for watching this video about how sea and land breezes form. So hopefully the next time you're sitting on the beach, reading your book or playing in the water, you'll have a little more knowledge about why the weather conditions are the way they are while you're having fun on the beach.